This video describes the theory behind using a handheld NOx meter for SCR diagnostics. Virtually all modern diesels run diesel exhaust fluid and SCR systems in order to bring NOx down to an acceptable level. The problem with this system is that the outlet NOx sensor that is on the truck can't tell the difference between NOx and ammonia. So that means when the SCR system begins to fail, my outlet NOx sensor, the sensor whose job it is to tell me how much NOx is coming out the tailpipe, might very well be lying to me. It may or may not be. So in order to diagnose the system, one of the two sensors that I use, inlet NOx versus outlet NOx, may or may not be lying to me as I'm trying to diagnose the vehicle. So as a technician, you know you can't have this. You have to have reliable numbers if you're going to diagnose the system properly. So we are going to use inlet NOx and outlet NOx readings on the scan tool and add a third number of true outlet NOx with the gas bench, and then I'll be able to very quickly diagnose what's wrong with my SCR. So to start, I want to show you specifically what it is what we're talking about, and more importantly, what we're not talking about. Here's a cutaway of my diesel exhaust system, and the part most folks are familiar with is soot reduction and regen. So my DOC and DPF on the left side here, the back pressure sensors and temperature sensors that are related to it, nothing to do with what we're talking about. This right here is what we're talking about, is my SCR. So it is inlet and outlet NOx sensor, an SCR catalyst, and a DEF injector. And that's it. Those are the components that we are diagnosing in order to reduce NOx emissions. So on the left, inlet NOx sensor tells me how much NOx emissions I have coming out of the engine. On the right, outlet NOx sensor tells me how much I got going out the tailpipe. I've got a catalyst where all my reactions take place, and a DEF injector for squirting equal amounts of ammonia into the exhaust to get rid of my NOx emissions. So if I got 200 parts per million of NOx emissions coming out of the engine, I inject 200 parts per million of DEF in the exhaust in order to make ammonia. Those two react, and I have very little NOx emissions out the tailpipe. With everything working normally, here is what I would see. So for argument's sake, let's say I'm driving down the road. My engine is putting out 300 parts per million of NOx. Computer sees it, injects 300 parts per million of ammonia into the exhaust. I have 90% or so reduction, meaning about 30 parts per million out the tailpipe. And my handheld gas bench would agree that that is truly what the outlet NOx reading is. My troubles with the outlet NOx sensor begin as the SCR system begins to fail. So notice in this scenario, I got 300 parts per million out of the engine. On my outlet NOx sensor is also reading 300 parts per million. It's showing I have no reduction. So that could mean a couple of things, right? My injector, my DEF injector might be totally plugged or unplugged electrically, or my DEF is totally bad. Maybe somebody put water in there instead of diesel exhaust fluid, right? It's a bunch of scenarios like that. However, if I measure my true NOx out the tailpipe with a gas bench, I know that none of those scenarios are true. I can see that I do have some reduction. I've got half reduction. And so I say, okay, I know my DEF injector can't be totally plugged off. I know my DEF can't be completely bad. But my ratio of 300 parts per million as measured by the vehicle and 150 parts per million as measured by the gas bench show me that I do have an SCR failure and a slip catalyst because it's letting ammonia out of there. So this is how a handheld gas bench can help me get to a diagnosis quickly, because it tells me really what's going out the tailpipe, not just what the vehicle thinks is happening. So we're going to look at two quick examples here using scanner data and tailpipe analysis at the same time. So here I've got an F450 with a 6.7 liter diesel. I've got 107 parts per million on the inlet NOx sensor and 434 parts per million on the outlet NOx sensor. So this is showing that I have NOx appearing in my exhaust system. And of course that can't happen, right? So what are my possibilities? I could have an inlet NOx sensor that's reading too low. I could have an outlet NOx sensor that's reading falsely high. I could have an overloaded SCR, meaning that it's full of its stored ammonia and leaking some out the tailpipe. I could also have DEF crystals in the exhaust, and when I'm accelerating the vehicle, those DEF crystals turn back into ammonia. They add themselves to the DEF that's already being injected, and I'm going to have ammonia slip out the tailpipe. So those are my possibilities, and I would have to eliminate them, a process of elimination step by step, if I wasn't able to look at tailpipe emissions. So now we add the gas bench and continue our road test. And so I can see that my outlet NOx reading on the tool matches the outlet NOx reading on the scan tool. So now I've just eliminated a whole bunch of stuff, right? I can see that my outlet NOx sensor is not reading falsely high by reading ammonia. So I've just eliminated that I don't have an overloaded SCR. I don't have DEF crystals in the exhaust. I don't have a failed SCR. My outlet NOx reading reads exactly the same as the gas bench. So that really only leaves one possibility on this, and that's the inlet NOx sensor is reading falsely low. This last quick scenario shows a failed SCR, and it's a failed SCR and failed slip catalyst because I do have ammonia out the tailpipe. So here's a reading. It's got 129 parts per million out of the engine, 87 parts per million out the tailpipe. So this is terrible reduction, right? At 129 parts per million out of the engine, I should have, 10 parts per million probably out the tailpipe. And in this case, I've got almost 100. So very poor reduction. So what are my possibilities? I could have crummy DEF fluid. I could have low DEF volume being injected into the engine. And I could have a failed SCR. So notice on this next screen here that even though my NOx numbers have changed, the outlet NOx sensor on the vehicle reads twice as high as the outlet NOx sensor on the gas bench. And this is a perfect example of how this sensor can become unreliable when it starts to measure ammonia. So this would make perfect sense, right? If I have a 1-to-1 ratio of NOx to DEF, then that means if I have unreacted NOx going out the tailpipe, I'm also going to have unreacted ammonia going out the tailpipe. And so here my NOx reading is falsely high as measured by the scan tool, and as measured by the gas bench, again, exactly half. So I know that my vehicle is now reading ammonia and NOx going out the tailpipe. And so here's a great example of one quick road test is going to help you diagnose this vehicle. On this truck, I also added a DEF fluid quality and quantity check. So, of course, you yank the injector out, command the test with your scan tool, measure the volume of DEF that it injects during its cycle. In this case, we pass at 40 milliliters, which is a spec for this truck. And we also do a fluid quality test, and I do that with a specific gravity tester. But this is a good test to add, I would say a necessary test to add to any SCR diagnostic. Of course, this stuff is weak acid. Make sure you follow manufacturer's test specs and precautions, and you'll have yourself a quick and complete SCR diagnostic.